Okay, let's get into this. We're doing a deep dive today on a piece of gear that solves a really fundamental problem in professional video.
A huge problem.
Right. How do you send a perfect high-definition signal over miles and miles without it degrading?
And the answer we're looking at is the DVIgear DVI-7345. It's a 3G-SDI fiber optic extender.
So, in simple terms, what's its core job?
Its job is basically translation. It takes a normal electrical video signal, an SDI signal, and it converts it into pulses of light.
For transmission over fiber optics.
Exactly. And it's built for really demanding places. Think live sports broadcasts, film sets, basically anywhere you absolutely cannot have a signal failure.
And that brings us to the first big point. Distance. This isn't just for running a cable across a room.
Not at all. We're talking about extending SDI, HDTVSupply, and even 3G-SDI signals over a single strand of fiber.
This single strand. And the standard distance is what, about 1.2 miles?
Yeah, roughly 2,000 meters. But where it gets really serious is the extended option. You can push that signal out to 6.2 miles.
6.2 miles. That's just over 10 kilometers.
And the reason you have to use fiber for that is, well, it's noise.
Right. Copper cable over that distance would pick up everything.
Everything. Radio interference, electromagnetic interference, you name it. Your signal would be a mess. Fiber is just completely immune to all of that. You get a pure signal at the other end.
Okay, so you've got the distance, but it's useless if the quality isn't there. Let's talk about the performance standards.
Well, that's the other half of the magic, isn't it? It maintains full compliance with the highest broadcast standards. We're talking SMPTE 424M for 3G-SDI.
And for anyone listening, 3G-SDI is, that's the professional benchmark, right?
It's the top tier. It demands data rates up to almost 3 gigabits per second. To maintain that level of quality over 10 kilometers with no repeaters in between, that's a serious engineering feat.
Now, the video specs are impressive, but the thing that genuinely surprised me was the audio capacity.
Yes. Most people focus on the video.
With standard HD and SD, you're getting 16 channels of embedded audio, which is already pretty good.
It is. But when you use that full 3G-SDI bandwidth, it actually doubles.
It jumps to 32 channels.
32 channels of 48 kilohertz, 24-bit uncompressed audio, all running down that same single fiber with the video.
That's enough for a whole orchestra, basically.
Or a massive festival stage. You're eliminating so much extra audio cabling.
So you have all this high-end, long-distance tech, and it's all inside this tiny metal box.
It's kind of ridiculous, isn't it? The whole unit weighs 1.5 ounces, 42 grams.
It's clearly designed to be, well, to be abused, really. It's meant for the field.
Absolutely. The connectors are all locking BNC for the SDI, rugged ST connectors for the fiber, so nothing gets accidentally unplugged.
And I saw a note about the dust covers.
Yes. I love that detail. They're twist-locking metal dust covers. Fiber is so sensitive to dust, and including that just shows they're thinking about long-term reliability in harsh conditions.
And speaking of harsh conditions, the temperature range is wild.
It really is. It's rated to operate from minus 40 degrees Celsius all the way up to a blistering 85 degrees Celsius.
So you could literally have this thing in the Arctic or in the middle of the desert, and it would just keep working.
That's the idea. Total reliability.
So to kind of bring it all together, what you have here is a tiny, incredibly tough little box that gives you pristine broadcast quality video and a huge amount of audio over miles and miles with zero interference.
It's a perfect example of a specialized tool that just does its one job flawlessly. So it kind of leaves you with a thought, right?
Go on.
This whole system uses just a single wavelength of light to carry all that information. 32 audio channels, high-res video over 10 kilometers. So as we move towards things like 8K video, which is just an enormous amount of data, how are engineers going to have to push this technology? How will they squeeze even more bandwidth and efficiency out of a single strand of fiber like this? That's the next big challenge.